Today we will continue our module 11 after completion of the supervised learning. I am going to demonstrate with the practical session on unsupervised learning by using unsupervised learnings. We are solving n number of complex problems. What is meant by unsupervised learning, Ramchand? How you can define your own sentence? Can you clarify?
Uh, yes, sir.
Yeah, please.
Uh, Unsupervised learning is all about we have unlabeled data. Like there is no target class, there is no labeled data. Still, I would like to classify the data. Um, uh, uh, I mean, I would like to classify the data um, by using the clustering algorithms like k-means clustering, hierarchical clustering,
Correct.
um, and then Gaussian mixed models,
Yeah, correct.
uh, and then
Agglomerative
principal component
clustering.
analysis, independent component analysis, autoencoders, SOM, that is self-organizing maps, and then T-distributed stochastic
Correct, correct.
near
You are
neighboring
absolutely correct.
embedded algorithms.
Perfect, Ramchand. You have given very good answer. This is my interview question. That's why I have asked. Very good
Okay, sir.
answer. Let me give you the correct and technical information about unsupervised learning. Unsupervised learning is one of the approach in machine learning. We have three approaches: supervised learning, unsupervised learning, and reinforcement learning.
Assessment
So
learning.
unsupervised learning is nothing but there is no label, there is no target class, but I would like to classify the data based on the similarity measure. How
There
to
are three
calc
types. One is Euclidean distance, one is
perfect Minkowski distance,
Minkowski
Minkowski
distance,
Manhattan
Min
distance.
Manhattan distance. Suppose,
Perfect.
for example, if we have 2 points, x1 and y1,
X2, Y1,
x2,
Y2.
y2,
Yes.
yeah, and then we have to say square root of x1 minus x2 the whole square plus y1 minus y2 the whole square
Perfect answer.
to find the
So,
difference between the
perfect.
2 points.
So that's why we are using a clustering algorithms under unsupervised learning. Clustering means grouping of data points based on similarities, grouping of objects having a similar behavior in the nature. Examples like customer segmentation for targeted marketing, and k-means and k-medoid partitions data into k clusters. We are using one of the clustering technique very popular. K-means k is a number of assumptions of the clusters. Example, document clustering based on topics. We are using k-means clustering. Suppose k is equal to means two clusters, k is
Two
equal to 3
clusters.
means three clusters.
Three.
Then what is meant by key? K is a assumption cluster. You need to tell. Okay.
Okay,
Okay.
sir.
Then hierarchical clustering is a top down and a bottom up. We are using single linkage and multiple linkage algorithms. So it builds a hierarchy of clusters. Example like a hierarchical taxonomy of animal species, etc. Then we are moving to dimensionality reduction, reducing the number of features while uh, retaining important information, like we are reducing noisy data, inconsistent data, redundant data of any given item or an image. Automatically unique features are stayed in that image, and the redundant particles we are eliminating. That is called a dimensionality reduction. Feature selection in a high dimensional data, like one dimensional, two dimensional, three dimensional we have. So we are eliminating noisy, inconsistency, redundancy, dirty data. Then it becomes very good refined image. So there we are applying principal component analysis technique like a PCA. So it transforms original variables into new ones that are linearly uncorrelated. Actually, in this PCA, what it does, we have a number of samples. Okay, but each sample is not related to another sample, maybe uncorrelated each other, reducing the dimensions of gene expression data. That means we have one dimension, two dimension, three dimension. In three dimension, if you take any image, maybe there are redundant particles, redundant data, noisy data, inconsistent data, dirty data. We are eliminating with the help of pre-processing techniques like box plot, binning, and filters, etc. Then it becomes we are reducing the dimensions of gene expression data. What are the top 10 unsupervised learning algorithms are there? K-means clustering. What is meant by clustering? It groups data points into K clusters based on feature similarity. That means suppose in a class we have 60 students are there, but I am clustering three groups like who are having 75% of percentage in one group, and the second group is 65 to 75 below. Next below 65% is one group. That means group of data points into K clusters. K is equal to 3 based on the feature similarity. What is feature here? Percentage. Ramchand, percentage
Yes,
is
sir.
a feature. Keep in mind. Then a hierarchical clustering is nothing but based on the root and children concept we are solving the problem. It builds a hierarchy of clusters using either agglomerative or divisive methods. We are solving the problems like DB scan. What is the expansion of DB scan? Density based spatial
Density based
clustering of
spatial
applications
clustering
with
for
noise. So here also we are grouping the data points based on density, based on the identifying clusters of arbitrary shape. That is called a DB scan algorithm, very popular. Then Gaussian mixture models like GMM, it fits data into multiple Gaussian distributions to form soft clusters. Principal component analysis we are using, like it reduces the dimensionality reduction while preserving variance by projecting data onto orthogonal components. That means all the orthogonal components are in a diagonal shape of the image. So if you are arranging all elements in a matrix 2 by 2 matrix, all diagonals the first element to last element in diagonal portion we are taking, those are the orthogonal components. Remaining are redundant particles we are removing with the help of PCA technique. Then independent component analysis, ICA, is nothing but it is one of the clustering technique. It separates a multivariate signal into additive subcomponents based on statistical independence. We are solving the problems. Then what about autoencoders? Autoencoders is one of the popular technique under unsupervised learning. We are using in generative adversarial networks. In even deep learning techniques, we are using autoencoders. Neural networks. What is neuron? Neuron is a biological element which mimics and combinations of neurons is called brain. Brain, how it is working based on the functionalities same as neural networks. Here artificial neurons we are creating, it is mimicking like our membrane of brain, and it is used for dimensionality reduction and feature learning by using autoencoders. Then eighth technique is t-SNE is nothing but t-distributed stochastic neighbor embedding is nothing but it is a visualization algorithm. That means diagrammatic representation of a algorithm for a high dimensional data. By reducing it to or three dimensions, we are solving the problems. Then a priori algorithm is nothing but It identifies frequent item sets and association rules. In transaction data, we are solving. Frequent item sets is nothing.
Example, abnormal transactions by a customer in a bank.
That is outlier detection. Very good answer for outlier
Oh,
detection. But here,
okay,
frequent
okay.
item set is nothing but Ramchand in Maldives is every week is going to market and purchasing bread and jam. Okay,
Okay, sir.
frequent
Got
item.
it, got it, got it. Okay,
Yeah.
got it, sir.
Then is
Let's say now
also
it's a month of Ramadan. So it's
yes.
a month of Ramadan where they'll be doing fasting. So they end the fasting by eating dates. So dates is the item that is sold in large quantity, especially during this month.
Oh, very good,
So
very good.
likewise, it varies depending upon the
Frequent item
different months.
sets. So you are going to one supermarket, that manager observing your behavior in the system. What type of items Ramchand is purchasing every week? Every week you are purchasing a few common items, you know. So that
Yeah,
common
like milk,
items
bread, egg.
they are extracting meaningful data from each customer, and they are increasing those items because they are getting very good sales. They are increasing their revenue by
Yes, sir.
using a priori algorithm, frequent pattern match algorithm. They are using to find the frequent item set mining. Are you understanding, Ramchan?
Yes, sir. Yes, sir.
Then what about isolation last technique forest? It detects anomalies. What is meant by anomalies? How can you define, Ramchan? Anomalies is
Anomalies.
nothing but it is a error. It is a mistake. It is a something is fishy. Something is a something is unknown thing is called anomalies.
Okay, sir.
That is called anomalies means something is error, something is nonsense, something is criminal activity, something I don't know. Are you understanding what I am
Okay, sir.
saying?
Yes, sir.
Yeah,
Yes, sir.
that is called anomaly detection. Ramchand, are you
Yes, sir.
understanding?
Yes, sir. Yes, sir. Something abnormal.
Perfect. Now you can tell that outlet you have told in the bank example. Can you repeat once again?
Yes, sir. Okay.
Yeah.
Yes, sir. Bank transactions. Let's say, for example,
Ah,
a bank in a remote location where customers do transactions, but the transactions will not go, let's say, over 10 lakh limit per day for entire customers in the bank who have the accounts. So the entire transaction in a day maybe 10 lakhs. But what
correct.
if a sudden change happens? Let's say for 5 to 6 days, one customer who is doing more than 10 lakh transactions per day. So that is something abnormal,
Correct.
transactions identified.
Correct. That it
Yeah.
detects the anomalies by randomly partitioning data and isolating anomalies in fewer steps. That is called isolation forest. And it comes under outlier detection. Keep in mind. Then we are moving to
Okay, sir.
reinforcement learning. What is meant by reinforcement learning? Do you have any idea? Can I explain to you?
Yeah, I can
Try,
define in
try.
my own words, sir.
Yeah, because you have
Um,
interview, that's why I'm giving the
Basically,
chance.
yeah. So reinforcement learning is all about, trying to train the agent based on the data that we have. Uh, Sometimes, we train the data, it may not give the proper outcome. It is basically a trial and error method, or, learning learning from the mistakes. The best example is the third algorithm, which is state action and state rewards, which means based on the punishments and reward, we are learning and then we are redesigning the model. It may take a number of steps before we find the perfect model for the usage purpose.
Perfect. Reinforcement learning is nothing but based on the punishment and reward, and we are solving the problems, especially in gaming applications like q learning, deep q networks, that is called dqn. SARSA, state action, reward state action, policy gradient methods, actor critic A2C and A3C, advantage actor critic, proximal policy optimization PPO, trust region policy optimization TRPO, Monte Carlo methods, and a deep deterministic policy gradient DDPG, soft actor critics SAC. These are the reinforcement learning to solve complex gaming applications. So reinforcement learning is one of the type in machine learning algorithm approach where an agent learns to make decisions by interacting with an environment and receiving feedback in the form of rewards or penalties to maximize cumulative rewards over time. That is called reinforcement learning. Reinforcement learning algorithms, especially Q learning. Q is nothing but a model free algorithm that learns a policy by estimating the action value function, that is called Q values, using a table or function approximation. Deep Q networks is called DQN. It combines Q learning with the deep neural networks to handle high dimensional state shapes such as those in video games or robotics. We are solving a reinforcement learning by using DQN. Then policy gradient method we used to call it as it is one of the famous algorithm under reinforcement learning that directly optimize the policy by policy means rules and regulation, keep in mind, that's all. Policy means rules and regulations.
Rules and regulations.
By adjusting its parameters using the gradient of the expected reward, that is called policy gradient method. Then what is meant by proximal policy optimization PPO? It is a state of the art policy, like before going to start your research you are doing a state of art. State of art says that what is the problem statement, what are the objectives of your research, what are the outcomes of the research, like that. So this policy optimization algorithm that balances exploration and exploitation while maintaining stability during training, that is called PPO. Then actor critic methods is called, it combines the benefits of value based critic and policy based actor approaches to improve learning efficiency and stability. Examples, it includes A2C, that is called advantage actor critic, and A3C, asynchronous advantage actor critic, etc. So, can you explain this example reinforcement learning? Some analogy, you can call it as an analogy. What is meant by analogy, Ramchan?
Okay, sir.
Please explain.
Analogy is all about uh, from the starting state and till the ending state.
Perfect.
What are the frequent steps and actions taken to
Ah,
proceed till the end of the state?
perfect.
Okay, so the first one is observe. Let's say an agent
This scenario
is
comes under reinforcement learning. How you are going to solve a problem? That is the main aim of this problem.
okay, sir.
You have environment.
Okay,
You
so
have three items. You
yes,
have
sir.
three items like a fire, bucket of water, and agent. Environment. Four
Yes, sir.
items are there. How you are going to solve this problem?
Right. So in a given environment, an agent is there, and there is a fire, and then a bucket of water is there. So first, the agent will observe, and then based on the selection, based on the policy, so it will have to decide which one to approach for. Because if it is going towards the fire, it will get melt.
Correct.
If it is going towards the bucket of water, it can handle the water, but it cannot use the water for its purpose.
Correct.
So it will decide, the action is like it will decide what to do and what not to do. And then let's say if it is getting closer to the fire, it may able to sense that something wrong is going to happen.
Correct.
So it is actually based on a punishment, because it sends the punishment, it is coming back to its original state,
Correct.
and then updating the policy to make sure that it does not go and touch the fire again. Once the policy is updated, and again it will try. Now this time it will go to the fire, but then it will understand it will get burned, so it will go to the bucket of water, and then it can handle the water. So this process takes several iterations, and until the agent completely learns, which is bad and which is good and how to avoid.
Correct. That is based on the
Yes, sir.
punishment and reward. We are solving the
Yes,
gaming applications. This is
yes, sir.
called analogy of reinforcement learning. Very good. If anyone asks you, you can take this example and you
Okay.
can explain in the interview. Okay,
Sure, sir. Sure,
Ramchan?
sir.
They will ask you definitely,
Yes, sir.
100% they will ask you.
Sure, sir. Sure, sir.
Then, what are the top 10 algorithms of reinforcement learning algorithms? We have a Q learning. It is a model free algorithm that learns the optimal action selection by policy by estimating Q values. Yes, we are selecting the policy. That means we are selecting the rule and regulation, then we are estimating the Q values. Then second one, deep Q networks. It is called a DQN algorithm under reinforcement learning. It extends Q learning by using deep neural networks to approximate Q values for high dimensional state spaces. And policy gradient methods is nothing but directly optimizes the policy function by following the gradient of expected rewards. Example, reinforcement algorithm. Then fourth one is a proximal policy optimization, that is called PPO, a state of the art policy optimization algorithm that ensures the stability and performance during training. Then actor critic method is nothing but it is a one of the top 10 algorithm of reinforcement learning algorithm. It combines value based and policy based approaches where the actor determines actions and the critic evaluates them. Example, A to C, A through C, etc. Okay. Then
Yes,
we
sir.
are going for Monte Carlo algorithm. Like we are using the policies like by averaging returns. I mean averaging returns sampled from complete episodes of experience. Then we are solving from complete episodes of experience. We are solving Monte Carlo problem. Sarsa is nothing but state action reward. State action is nothing but an on policy algorithm that updates key values based on the policy being followed, means rules and regulations for each algorithm we are following. Then we can call it as a trust region policy optimization, that is called TRPO. It is a policy gradient algorithm that improves stability by limiting the step size of policy updates. Okay. Then uh, policy update by using TRPO we are solving. Soft actor critics is nothing but SAC. It is a robust algorithm, means if you increase number of any policy, any rules and regulations, still that algorithm can solve the problem. That optimizes the stochastic policies while balancing exploration and exploitation. And double Q, you can call it as double Q learning is an extension of Q learning that reduces overestimation bias by using two Q value estimators under double Q learning. So these are the machine learning approaches. Can you see and explain, Ramchan? I want to listen from you. Can you
Okay,
try?
sir.
Yeah.
So when we talk about machine learning, it is of three types. One is supervised learning, second one is unsupervised learning, the third one is reinforcement learning. When it comes to supervised learning, it is all about we have a label data, we have a target class, So, we would like to, I would like to classify the data based on the algorithms that supervised learning has. One is um, linear regression, logistic
Correct.
regression,
Correct.
and then when it comes to classification, again, classification is divided into, classification with quite a few algorithms like k nearest neighbor, neighbor Bayes, logistic regression, support vector machine, decision trees. When it comes to unsupervised learning, let's say we don't have a label, we don't have a target class, but I would like to classify the data um, based on the clustering algorithms, association rule learning. So when it comes to clustering, K means clustering, DB scan, which is data based
Mm.
stochastic
Correct.
clustering applications with noise.
Correct.
And then the next one is so the next one not able to see, sir.
Which one?
In clustering, sir.
In clustering, see,
After
you
DB
are
scan,
you are
after DB scan.
youngster actually. Mean shift, fuzzy C means agglomerative. What else in clustering?
Yeah, no, no. To me, the screen is too small, so not able to identify the text. Agglomerative, isn't it, sir?
Agglomerative. Yes, correct.
Agglomerative. Okay,
Mm,
sir.
mm.
And then when it comes to association rule learning, it is FP growth a priori algorithm. A priori algorithm is basically for association rule learning. And then is it? I don't know. It's too small to me, sir.
Which
Is
one?
it after FP growth before a priori? Above the a priori.
Above the a priori, that is EUDAT, U dot.
U dot. Okay, sir.
Uh,
Okay. And then in unsupervised learning, again, we have a dimensionality reduction, uh, which is a principal component analysis. Uh, and then is it ISNE, sir?
yeah, t-SNE. Yeah.
t-SNE.
Uh,
Is it T distributed stochastic
yes.
neighboring embedding?
Correct, correct. Dimensionality reduction.
Yes, reduction. Yes, sir. And then principal component analysis. And then is it LDA, sir?
Yes, LSA, PCA,
Okay,
SVD, LDA, linear discriminant analysis.
analysis. Okay, sir.
Support
And
vector
then
dimension. Yeah.
yeah, support vector. Is it
Dimension.
SVD, sir? Support vector
Vector
dimensionality
dimension.
dimension.
Yeah. Linear state aggregation.
Yes, sir.
Principal
And then
component analysis. Okay, you know. Next, coming to.
yes, next is ensemble learning.
Yeah.
Ensemble learning. Is it stacking, sir?
Yes, correct.
To me, it is very small. That's why I'm not able to read.
For me also small only. I am using already specs. Huh? Huh? You are younger than me. Which one?
Yes, sir.
Stacking, random forest, bagging, XGBoost, and boosting, light GBM, gradient boost, managing, ADA boost, call boost. Next, coming to neural networks and deep learning.
Neural network and deep learning.
Yeah.
Conjugational,
Convolutional
computational
neural,
neural network,
that is
convolutional
CNN.
neural network,
Yes.
and then recurrent neural network,
Perfect.
generative
So
generative
DCNN
adversarial
means
neural network,
there in the convolutional neural networks we have a DCNN, deep convolutional neural networks.
neural network. Okay, sir.
Mm.
And then
LSM
recurrent
means
neural
long
network.
short term memory.
Okay, long short-term memory. And
LSTM
then
long
this.
short term memory again. Same thing.
Okay, sir.
And GRU means graphics recurrent unit
Okay, sir.
or generative recurrent unit, you can say.
Okay, sir. And then adversarial neural, sorry, generative adversarial networks. And then autoencoders.
Yeah.
Autoencoders. No, this word I don't know. What else?
Which one?
Below the autoencoders.
Ravi, I'm in class, Ravi. I'll call you after some time. Sequence to sequence. SEQ to
Okay,
SEQ.
sir.
Message me, Ravi.
Okay, sir.
Ah. Then you can call it as reinforcement learning.
Yes, sir.
Yeah.
And this is perceptrons.
Perceptron. Yeah,
Perceptrons.
perfect. Yeah. Anything else left?
Ye- Yes, sir. I have read everything, sir.
Yeah, perfect. This is called machine learning approaches so far we have. And what is meant by predictive analytics is nothing but it determines the future outcomes, likelihood, by using techniques like data mining, statistics, and artificial intelligence, artificial neural networks, machine learning, deep learning. Okay. Simply, we are applying predictive analytics, interprets an organization historical data, that means legacy data, to make predictions about the future values by using predictive analytics. Suppose we have any number of data sets we are pre-processing, Michigan data sets, suppose you are taking. We are extracting feature selection. Then we are applying modeling like five-fold cross validation. Then tele-awived data set we are using, feature selection we are performing in the yellow line. Modeling five-fold cross validation. Then Michigan plus tele-avive data set combinedly we are using, and we are performing feature selection by applying modeling and five-fold cross validation. Then there are yeah, 75% of training data we are using, 25% of validation and testing we are using, Michigan plus Tel Aviv. Okay, so our aim is to predict and interprets an organization's historical data to make predictions about the future value. In traditional approaches, we have data, program, computer, and it gives output. Machine learning, what it does, it takes data, output, then computer, then model it can give. So, in this traditional approaching or modeling, we have prediction data and handicrafted model. Then we are using computer, it gives result. Machine learning, what it does, we have learning, first sample data, expected results, then we are moving to computers and model is nothing but simplified version of the reality. Then prediction, we are giving a model input to the prediction. There we are using new data model, then it gives us a computer and result output. Likewise, a traditional modeling and machine learning. So this is a broad diagram of machine learning, like supervised learning, unsupervised learning, and reinforcement learning. Under supervised learning, we have two classifications like classification and regression. Under classification, we have examples like fraud detection, best example, email spam detection, best example, diagnostics is a best example, image classification, best example, regression, we are applying risk assessment and score prediction. Unsupervised learning is nothing but a dimensionality reduction. There we are using text mining, face recognition, big data visualization, image recognition, etc. Then clustering, we have biology, one cluster, city planning, one cluster, targeted marketing, one cluster, etc. Reinforcement learning is nothing but gaming, finance sector, manufacturing, inventory management, robot navigation, etc. The four different types of machine learning are supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. If you see that machine learning, we have a fantastic machine learning algorithms like supervised learning. We have regression. Under regression, we have linear regression, polynomial regression. Under decision tree, we have that is even random forest comes under decision tree. Then classification is one of the supervised learning approach. We have
K nearest neighbor,
yeah, k nearest neighbor algorithm,
decision
decision
trees,
tree, logistic regression,
logistic
naive based
regression,
classification, support vector
support
machine.
vector machine,
Yeah, please explain like that. Under clustering, support vector dimension, principal component
uh,
analysis,
principal component analysis, K
K
means
means
clustering,
correct.
association analysis, a priori
Correct.
algorithm
FP means
for
frequent
association,
pattern.
rule learning,
Hmm.
FP growth,
Frequent pattern growth algorithm. Keep in mind.
frequent
Frequent.
pattern. Okay.
Then we have hidden Markov model that is called HMM, very popular technique. Then
Okay,
we
sir.
have reinforcement learning. These clustering
Mm.
SVD, PCA, K-means are continuous. Whereas in association analysis, a priori and FP growth, we have categorical data. These are the types
Sir,
of
1 minute. SVD, can you explain once again, sir?
support
SVD.
vector dimension. What it does, we have a hyperplane. You know support vector machine, what it does, SVM? Same thing. But here dimensions are more, that's all. So we have a hyperplane.
Okay.
In a x-axis and y-axis, we have a hyperplane. Below the hyperplane, we have one cluster. Above the hyperplane, we have one more cluster. That is two dimension. If it is three dimension, then we are going for SVD. That is called support vector dimension. SVM you can give for two dimension also it can solve. Any doubt? It is
No, sir.
okay.
Correct. Clear, sir.
Okay. Then we
Clear,
are
sir.
yeah. Then we are moving to again. This is classifications examples under reinforcement learning. Remaining algorithms, I guess you know very well. Then we will solve practicals these algorithms. They are under reinforcement learning. We are going for state and action. Whereas see how simple you have to remember. Supervised learning deals with the data with label. What is that meaning? Based on the
Um,
label, based on the target class, we are classifying the
with
data.
class
That is the
data.
meaning of data with label. Now can you explain?
We
In a
have
class,
label, we have
I
target.
will give you an example. In a class, gender is a label. Based on the gender, we are classifying girls versus boys. That is called a data with label. Okay. Now you explain.
Okay, sir. Okay, so supervised learning is all about data with label.
Correct.
Let us take students as example in a classroom. When we have what do you call gender as a data,
Mm.
we have boys versus girls.
Correct.
Um, So it has we use classification algorithms like logistic regression, Navy Bayes classifier, K nearest neighbor,
Correct.
support vector machine.
Correct.
Examples are email spam detection, speech recognition,
Correct.
and when it comes to regression, linear regression,
Regression
ridge
means
regression,
based on the past values, we are predicting the future value.
predicting the future values.
Correct. Mm.
Yeah. Um, so the best example is stock market prediction, rainfall prediction,
Correct. Next.
like weather forecasting.
Next answer. Like
And
that, I explain remaining two
unsupervised
approaches. Hmm.
uh, for unsupervised learning, there is no label, there is
Correct.
no target class, but
Based on the
we would
similarity
like to
measure, we are
classify.
solving. Like that, you need to explain.
Yeah, yes, based on the similarity measures, we would like to solve the problems.
Hmm.
So it has clusters, which is k-means clustering algorithm,
Hmm.
k-median clustering algorithm, hierarchical clustering, um, expect exception maximization,
Hmm.
example,
Hmm.
identifying the fake news,
Hmm.
and then document analysis,
Hmm.
and then association analysis, a priori algorithm,
Hmm.
um, ECLAT,
Hmm.
FP growth. Just now you said, sir, for FP growth,
Hmm. Frequent pattern.
uh, frequent pattern, is it, sir?
Pattern. Yes, correct.
frequent pattern growth. Example, market basket analysis. Then the third one is dimensionality reduction, for which feature extraction, um, in which there is a principal component analysis, and then feature selection. First one is wrapper, filter, and then embedded method. Example, analysis of a written text and DNA microarray data.
DNA means deoxyribonucleic acid. Yeah, even we are our with parents we are getting DNA sequence.
Yes, sir. And then the last one is reinforcement learning. So reinforcement learning is all about based on punishments and reward.
Correct.
We are training the model n number of times until we obtain the desired outcome. So basically, state and action. The first one is Q learning. Second is hybrid. The third one is policy optimization. Policy is nothing but rules.
Rules
And
and
then
regulations.
rules and regulations, model based. The first one is learn the model and then given the model.
Correct. So that is about reinforcement learning. Then we are moving to this one already we have solved, na?
Yes, sir.
Oh, why it is coming once again? No. Yeah. Yeah. Now, can you explain once again? It is very
Yes,
powerful.
sir.
Yeah.
Yeah. Machine learning, and when we talk about machine learning is all about three types. One is supervised learning, other one is unsupervised learning. So in supervised learning, we have a label, we have a uh, target class,
Perfect.
but yeah, we would like to
Classify the data.
classify the data based on the
Label
similarity, based on the label
and target class.
and target class.
Perfect. We
So
have two
yeah,
approaches again.
yeah, the two approaches are classification and regression. One is logistic regression. I mean, in classification, we have logistic regression, classification trees,
Correct.
basically the decision trees,
Correct.
and then support vector machine
Hmm.
and random forest, artificial neural network.
Correct.
Whereas in regression, we have linear regression, regression trees,
Correct.
um, Bayesian network,
Correct.
fuzzy classification, artificial neural network.
Correct.
And then in unsupervised learning, we have label. I mean, we don't have label, we don't have
Correct.
target class, but
Correct.
I would like to classify the similarity measures
Correct.
based on the Euclidean distance or Manhattan distance, Minkowski distance. For
Minkowski.
example, if we have 2 points, x1, y1, and x2, y2, we can find the difference with the help of a square root of
X1 minus
x1
x2.
minus x to the whole square plus y1 minus y to the whole square.
Correct.
So in clustering, there is a K-means clustering algorithm, hierarchical clustering algorithm, a Gaussian mixture model, genetic algorithm, artificial neural network. Whereas in dimensionality reduction, we have a principal component analysis, tensor decomposition, multidimensional statistics, random projection, artificial neural network.
Perfect, Nana. So this is also same thing. I think you can remember some examples. Can you explain what are the examples of these approaches?
Okay, so when we talk about let's say dimensionality reduction, the first, let us take big data into consideration. Big data visualization. So basically, when it comes to visualization, by using Power BI or Tableau, we can do the data visualization, because data visualization is all about exploratory data and explanatory data.
Correct.
So a graph of dashboard will give a clarity about each and every point of the data, which is shown in the Excel sheet or any Tableau or any Power BI used visualization. Um, and then when it comes to, let's say, classification and supervised learning, financial fraud detection, um, and then customer retention can be predicted. And then when it comes to reinforcement learning, let's say game artificial intelligence, because when we are trying to train an agent, I mean, there may be punishments and rewards. So based on the punishments and rewards, we can retrain the model, and then we can deploy the model for usage.
Correct.
Yes, sir.
Perfect explanation. Then we have for each algorithm small explanation is there. Can you read Ramchand and I will explain?
Uh, Sir, actually, since you are sharing the screen, the text is to me is even more smaller. Maybe to you it is better for clarity.
Okay.
Otherwise, I'll have to open the PPT and then read. Sir, what should I do?
It's okay, no problem. Can I will explain, don't worry.
Yes, sir.
Yeah, linear regression is nothing but based on the samples. We are selecting the independent variable and we are taking the sample variables and independent variable and dependent variable. So based నేను క్లాస్లో ఉన్న మళ్ళీ చేస్తా. So we are solving the problem based on the independent variable and dependent variable by using linear regression. Y is equal to mx plus c. There we are using non-linear regression, logistic regression, etc. Classification and regression trees we are using. Like decision trees are an important type of algorithm for predicting modeling machine learning algorithm. Then k nearest neighbors, like we have a number of points, which point is similar to another point by based on k nearest. K means number of clusters. Based on that one we are solving the problem. Then machine learning is nothing but it is approach. It includes learning from data inputs based on what has happened. That is called a machine learning. Support vector machine is nothing but based on the hyperplane. We are classifying the data below hyperplane, above hyperplane. That is called support vector machine. Q-learning is a model-free reinforcement learning technique. It is able to compare the expected utility of the availability actions for a given state without requiring a model of the environment. Then what is the next algorithm? Above logistic regression, what is that algorithm? Ramchan?
Yeah, it is a linear discriminant analysis. Below
LDA.
is Navy based.
Ah.
Yeah.
Yeah, that is a linear discriminant analysis is a one of the generalization of Fisher's linear discriminant. It is a method used in statistics, pattern recognition and machine learning to find a linear combination of features that characteristics are separates two or more classes of objects or events in LDA, linear discriminant analysis. Then what about logistic regression based on the true or false, on and off, 0 or 1, and it learns from the field or statistics. It is the go-to method for binary classification problems. The naive based classification is one of the classification technique, or it is a clusters or family of sample probabilistic functions and classifiers we are using based on the independence assumptions between the feature values. Then learning vector quantization. So it is learning from different sources, and we are solving n number of hidden and input layers, and we are getting the output values based on the bias and fine tuning parameters and dropout function, activation functions.
Sir, can we say this is deep learning?
Yeah, it is a deep learning under approach. Bagging and boosting random forest comes under one of the classification technique. And bagging a simple parameter which is the number of trees. All trees are a fully growth binary tree. Random forest has two parameters. Then we have these are the various algorithms we are using. Boosting and ada boost also one of the machine learning approach. So it is a gradient boost and you can call it as a generalized boost between boost as some commonly used algorithms under this approach. So these are the machine learning tools we are using, like R programming, it is a visualization tool. We have a statistical mathematical tools like R, Scilab, SAS, SPSS, PSPP. Okay. What is meant by SAS? SAS is a statistical analysis software. Keep in mind, Ramchan. R is a
Yes.
visualization programming language. Scilab is a one of the statistical mathematical software. SPSS means social. Statistical package for social sciences. You know, SPSS tool. It is IBM product. Then stats model, SciPy, NumPy, and comes under statistical mathematical. Then we have machine learning tools like general purpose. We have scikit-learn, Veka 3. You know Veka expansion, Ramchan?
No, sir.
Veka, W stands for Vaikato, environment, knowledge for analysis. Veka is a flyless bird. Flyless bird in New Zealand, Waikato University, two professors invented this Veka tool.
Okay, sir. Okay.
Veka is a flyless, sorry. Veka came from Mecca. Mecca is a flyless bird at New Zealand, Waikato University. If I become a permanent residency, then I can go without visa to New Zealand. From here to New Zealand, 3 hours only. Ramchan.
Oh, great. Oh, super, sir.
I'm waiting for that PR. Permanent residency means green card.
Okay, sir. Okay, sir.
This month I'm expecting. So in this general purpose we are using rapid miner. It is also one of the data mining tool. MATLAB is a matrix laboratory. Octave, Shogun. These are the general purpose machine learning tools. What about narrowed solutions? XGBoost and Wowpal Wabit, LibLeaner and LibSVM. Lib means library. NLTK is nothing but Natural Language Toolkit,
Toolkit.
GenSim. These are the narrowed solutions of machine learning tools. Then what about interactive platforms? We have a Jupyter, Zepline, Orange, Kibana, Grafana, Tableau. These are the visualization and
Session
interactive
tool.
platforms. Okay. Machine
Yes,
learning,
sir.
deep learning with MapReduce. We have a deep learning 4J, H2O or deep water, Spark ML and a machine learning library, Fink a machine learning, ORYX2 ML. These are the machine learning, deep learning with MapReduce. What about deep learning with GPU? Graphics processing unit. Ramchand, you need to remember.
Yes, sir.
We have a TensorFlow. We have CNTK, Cafe 2, Torch, PyTorch, MaxNet, Theano, Chainer, Paddle, Mat Convenet. These are the deep learning with the graphics processing unit. And the last one is a deep learning wrapper libraries like Keras, Gluon, TensorFlow, Tensor Layer, TensorFlow Learn, and Lazang, Nime, NVIDIA Digits. These are the various machine learning tools we are using. This is machine learning engineer roadmap. What is machine learning engineer can do? First, he need to have knowledge on mathematics like probability and statistics and discrete mathematics. Then you need to have any one programming language like Python, R, and Java. Who developed Python? Guido van Rossum. Who developed R? R is a visualization programming language, and Larry Ellison, I guess. Let me check later. Then Java is a James Gosling. He proposed the Java programming language. Then we have a MySQL like database, MySQL Mongo database. Then we have a machine learning algorithms like linear, logistic regression, k nearest neighbor, k means, random forest, and more. Machine learning like machine learning libraries and non-machine learning libraries. Machine learning, scikit-learn, supervised learning, linear supervised learning, and reinforcement learning. We have deep learning like TensorFlow, Keras, neural networks, CNN, RNN, generative adversarial networks, long short-term memory techniques, data visualization tools, Tableau, ClickView, Power BI, machine learning engineer. Finally, you become. Then developer tools, we have statistical platforms or for diagrammatic representation, we are using R tool. Keep in mind, Ramchan. Then
Okay, sir.
pandas for data science, data sets explanation for exploratory data analysis tool. Then predictive modeling markup language, PMML. Predictive model markup language. Predictive model markup language. Then we have scikit-learn machine learning model builder, portable formats for analytics, Mongo database. It is unstructured data, Mongo database, Ramchan.
Yes, sir.
Then we have it is a scriptable databases. Then we have Hadoop MapReduce, Storm real-time analytics, Spark iterative analytics, and frequent pattern field something is there, FPGA. Field frequent generative analysis and ASICs, GPUs, generative processing unit or graphical processing unit, and co-processors, client side web browsers. Then we have machine learning tools. Just now I have explained, but it is not visible, I guess. Ramchan, very tough.
Yes, sir. Yeah.
Okay, I will remove this slide. No need of this slide. Then machine learning softwares like Veka. Can you expand Veka expansion? Vaikato, environment,
Uh,
knowledge
Environment.
for analysis.
Okay.
What is
Waikato
Veka?
environment knowledge for
Analysis.
analysis.
Veka came from Mecca. Mecca is a flyless bird.
Okay, sir.
Okay. And it is a data mining tool for analysis purpose. And Apache Spark machine learning library. RapidMiner is a data mining tool. H2O.ai is a artificial intelligence tool. Shogun is a artificial intelligence tool. Nime knowledge. Uh, knowledge interactive machine engineering tool. It is a data mining tool. ORYX2 is a artificial intelligence tool. Apache Mahout is a machine learning tool. PyTorch is a machine learning tool. TensorFlow is a big data artificial intelligence tool. Keras big data and artificial intelligence tool. So these are the advantages we are getting. Easily identifies trends and patterns. No human intervention needed. Continuous improvement. Handling multidimensional and multi variety of data. Wide applications. Then we are moving to disadvantages like a high error susceptibility, data acquisition, disadvantages like interpretation of results, time and resources. Then these are the applications we can see in real-time environment: image and speech recognition, medical diagnosis, statistical arbitrage, learning associations, classification, prediction, extraction, regression. Then these are the top 10 applications of machine learning. Automatic language translation, that is called in natural language processing, medical diagnosis, stock market trading, online fraud detection, virtual personal assistant like Google Assistant, and Siri, okay, Google Assistant, Siri, Alexa, etc. Email spam and malware filtering, self driving cars, product recommendations, traffic prediction, speech recognition, image recognition. These are the fantastic applications of machine learning. These are the formulas we are using for naive Bayes and k nearest neighbor. See, k nearest neighbor I have explained, x1 minus x2 whole square plus y1 minus y2. Here also they are using similarity measure, support vector machine, and then perceptron, neural networks, back propagation, gradient descent, linear regression, principal component analysis, and logistic regression, etc. So these are the major challenges of machine learning professionals. Poor quality of data. You will get a poor outputs only. Underfitting of training data. Suppose data set is very less. It cannot perform very good results. Overfitting means if the machine allows such a data set, then it can perform. If more than system allows, then it can call it as a overfitting of training data. Lack of training data and imperfections in the algorithm when data grows. So these are the challenges we have. Relationship establishment, difficulty in feature like recognition, classification, insufficient data, high degree of research specialization, poor generality of the algorithm, poor model interpretability, etc. We have challenges in machine learning, deep data preparation, model training, model deployment. So these are the top 10 algorithms we are top 10 libraries we are using. NumPy, still we are using same thing. Not only 2023, it is 2025 also same thing we are using. Then SciPy, Scikit-learn, Theano, TensorFlow, Keras, PyTorch, Pandas. These are the various machine learning top learning algorithms. NumPy for data visualization, data description, Ramchan, keep in mind.
Okay,
SciPy
sir.
means scientific Python for calculating various applications. Scikit-learn for machine learning algorithm. Theano for artificial intelligence. TensorFlow for big data application. Keras for big data. PyTorch for machine learning algorithm. Pandas. Why Python for ML? More flexibility, visualization ability, code simplicity, platform independence, better libraries, larger community. So these are the various algorithms we are using: linear regression, logistic regression, decision tree, random forest, gradient boosting, neural networks, etc. Then we will stop here, Ramchand. We will solve tomorrow with the practical session.
Okay, sir. Okay, sir.
So these are the practical session tomorrow. Next tomorrow, we'll
Okay,
start
sir.
with top 10 major algorithms. Okay,
Okay, sir. Okay, sir.
top 10 machine learning algorithms we will solve. Okay, so we'll explain this one also, no problem. Up to this one I have
Okay, sir.
explained, and I will stop here. 1 second.